The Synchronizer test module is composed of several views. The test view provides 4 tabs to parameterize the test. The sync view contains the relay's synchronization characteristic. It shows the difference in voltages versus the difference in frequency from System 1 and System 2. The test points will be depicted in this diagram. The synchronoscope displays the phase difference between System 1 and System 2. The solid green lines represent the allowable phase difference, while the green dashed lines symbolize the tolerances entered in the test object. When the test is started, the blue arrow rotates in order to show the phase difference that is being measured between the two systems. The higher the frequency difference between the two systems is, the higher the rate of change will be for the phase difference. The blue arrow stops when the relay issues the circuit breaker close command. A red arrow appears after the closing time to show when the circuit breaker is actually closed. The time signal view and the report view are available as in the other modules. Now we will focus on the settings of the test view. The Settings tab contains common testing parameters that are used by the different test modes, that is, function, adjustment, and auto test modes. During the pre-synchronization time, the voltages are output by the CMC test set, but no start signal is issued to the synchronizing relay. This allows the voltages to stabilize. At the end of the pre-synchronization time, the start signal is issued. The maximum synchronization time limits the amount of time for each test point. Only when the synchronization is achieved within this time can the test advance into the post-synchronization period. During this time period, the CMC test equipment continues to output voltages and it sends the release command. The minimum post-synchronization time that can be input depends on the start-release type defined in the test object. If set to continuous or none, the minimum post-synchronization time is the CB closing time. If set to pulse, as in our case, the minimum post-synchronization time is the higher value between the circuit breaker closing time and 500 milliseconds, which is the pulse duration issued by the synchronizer. If no synchronization is achieved, a release signal is sent to the relay and the test for this point is finished. The delay is the time in between 2 points during which no voltages are output. Once these time settings are entered, we can proceed with the first test. The Function tab checks the correct performance of the circuit breaker close command under different operating conditions. Based on the synchronization conditions defined in the test object, the module compares the nominal response that is expected with the actual behavior of the relay. As a result of this comparison, the test point is assessed as passed or failed. Remember to check the local hardware configuration before configuring the test module. To get points into the table, you can either use the input fields or add a point directly from the sync view. Use the Quick Test option to add a total of 8 points at the tolerance borders. This is a quick way to insert meaningful test points into the test table. We will use the Quick Test option, but we will shift the points where the frequency difference is 0. This is because the relay requires a certain frequency deviation to work properly. For the test points within the synchronizing window, the relay should issue the circuit breaker close command. For the outside points, the synchronization is not possible. Now we press play to run the sequence of test points. For each test point, the synchronoscope shows the relay's close signal and the moment that the circuit breaker is actually closed. Since it is not possible to run two different test modes in the same module, we must add an additional synchronizer module to the OCC file. This time, we will run the adjustment test. This test allows us to check the actuator commands issued from the relay to the generator. Do not forget to check the local hardware configuration to ensure that all signals are enabled. The principle behind the operation of the relay is to bring the generator into synchronization by means of the voltage and frequency control commands. The Synchronizer test module detects these commands and changes the outputs in accordance with the generator model that has been previously defined. The relay has to issue the control signals until reaching synchronization conditions. During the controlling process, all points are driven to a specific target point inside the synchronizing window. This target point depends on the logic and configuration of the relay, in this case, 40 MHz and 0 volts. However, keep in mind that the relay will issue the close command as soon as all the conditions are met, whether the target point has been reached or not. The module will check that the time elapsed between the start signal and the CB close command is within the maximum synchronization time. At this point, we need to specify the mathematical model of the generator. It is used by the CMC to simulate the behavior of the generator when the relay issues actuator control commands. The Synchronizer test module can work with the predefined generator models or user-defined models. In this example, the generator follows a linear model. The voltage and frequency change ratios are 4 volts per second and 150 millihertz per second. Now we add 4 test points to the table, all of them outside of the synchronizing window, and we start the test to assess the results. As we can see, the results are successful for all test points. Therefore, the conditions were met within the maximum synchronization time. In the sync view, you can trace the trajectory of each test point from the starting position to the moment that the relay issues the circuit breaker close command. Finally, remember to check the time signal view if you want to see and perform measurements on the recorded signals.